Three. Order. Welcome to this morning's session of the Business, Energy and Industrial Strategy Select Committee for our first hearing of our new inquiry on semiconductors in the UK, looking at opportunities and vulnerabilities to the sector. And in our first panel this morning, we're delighted to welcome Martin McHugh, who is the CEO of the Compound Semiconductor Application Catapult, and his colleagues Alistair McGibbon, who's an industry expert, and Dr. Andy Sellers, who's the Strategic Development Director. Good morning to all three of you on the screen. Martin McHugh, if I can come to you first. I think this is probably the first time a select committee, certainly recently, has looked at this issue, and we've been getting our head around the difference between silicon chips and compound semiconductors. And my understanding is silicon chips have silicon in them, that should probably be obvious, and compounds have silicon and some other materials. And I understand that in the UK we're particularly strong in the compound semiconductor sector. If all of that makes sense, please can you say so, and also explain what that means for the UK from its strategic position within these often complicated global supply chains.
Okay, thank you very much. So your description of a semiconductor as a single material, mainly silicon, is correct. It's what's driven the electronic system integration for the last 30 or 40 years. It's probably been the main technology for miniaturization and for everything that we've got used to in our electronic world. Compound semiconductors, as the name implies, is actually made up of two materials. A common one would be silicon and carbide, called silicon carbide. That's a particularly interesting combination of materials because it has the ability to handle far more power than conventional semiconductors. So it would be extremely useful in furthering the development of electric vehicles, for instance. Other compound semiconductors, GaN technology, would be useful for taking us from 5G to 6G. The other key advantage of compound semiconductors is that they can actually detect and emit light, which makes them very useful for sensing applications in future robotics and AI applications. So the UK typically, as it is often an early adopter and an earlier starter in technology investment, the UK has actually spent nearly 800 million in research for compound semiconductors, and actually has a pretty good leading position in the world in terms of research and development. And obviously this catapult is actually based in one of the only compound semiconductor cluster in the world at the moment. So the purpose of the catapult, to answer your question about the supply chain, is really to help that transition of the research into industry, hence we're called an applications catapult, and to actually help companies make their products more competitive by adopting compound semiconductors. So we're at that turning point now where it's critical that the various supply chains come together, the industry comes together, and we actually take that incredible amount of research that the UK has built up over the last 15 to 20 years and make sure that's commercialised.
Thank you very much. Mark Pawsey, please.
Thank you, Chair. Just following on from that point, if I may, you told us that we spent £800 million on research. We're in a leading position. How many people know that?
That's a very good question. I think within the UK, it's well understood that we are leading researcher in terms of compound semiconductors. What we're doing at the moment ourselves and other clusters within the UK are working on getting that message out now about this particular cluster being the only one that's actually in the world. But it's something that we have to work on, something that the UK itself has to come to grips with and promote.
If we have that lead, is it your assessment that government understand that? Do decision makers in the building we're in today know that we've got this leading position? Because all we hear about in respect of semiconductors is the problems caused by shortages.
Right. So the compound semiconductors are a particular field within the broader framework of semiconductors. So most of the supply chain shortages at the moment, all of them are actually connected with the broader semiconductor market. So compound semiconductors hasn't got to the point yet where it's actually caught up in the supply chain issue.
Okay, but how do we get to have better understanding here of the valuable role that the work you're doing and this particular sector has? Because we don't know that at the moment.
No. So that's part of the role of the catapult, is to actually get those messages to the market. You know, it's a good reason why we wanted to be part of this select committee, is to get the visibility of compound semiconductors into a wider audience.
Okay, and does industry more broadly understand the lead we have in this field?
The industry that's actually involved in compound semiconductors...
No, I'm talking about the people who would actually use the semiconductors. Do they know that we're ahead in this area?
It's a mixed picture, if I'm honest with you. So those that are actually using compound semiconductors realise that we are ahead. On the periphery, then, we have to extend that message to, and that's part of the role of the catapult, to actually encourage people to adopt the use of compound semiconductors to make their products more competitive.
Okay, and how can you go about doing that? How can we take advantage of this lead that you say we have?
I'd like to invite Andy, our Strategic Development Director. I think it's actually in quite a good position to answer that question, if that's okay with you.
Thank you.
Yeah, thanks.
Thank you, Martin, and thank you for the opportunity to address the committee. You're quite right. So Martin has indicated that the UK has invested over £800 million in the research of compound semiconductors through the universities, and the role of the catapult is to translate that research into actual applications. Now, we have, and in terms of the recognition, Innovate UK has recognised our leading position, and Innovate UK has established the catapult in order to drive that role. I think how we can help do this is to look at the large markets that we're looking to address. So the net zero market of vehicle electrification and smart energy grids is one of the large markets. 5G, 6G communications, satellite communications, and quantum technologies. By identifying these large markets, we can build the supply chains and build the UK semiconductor industry to supply those supply chains. And I think it was a great opportunity. I think Innovate UK are certainly recognising these programmes. Innovate UK, the UK's innovation agency, has funded the quantum programme very, very extensively. And it's these kind of programmes which are bringing industry together to translate the work from early stage research out to commercial applications. Okay, and is there an everyday product that we will use, that we could say has a UK-based conductor in it? There certainly is, yes. So if I can point to one very good example that actually my colleague Alistair has led on. We have built the entire supply chain for a power unit that goes into a McLaren electric sports car. It uses the semiconductors that are...
It's not exactly every day, but nonetheless it's a good example.
It's a good example, but also the catapult works with very innovative companies to take risky products to market faster. So naturally, we tend to work with a highly innovative company that might be a smaller volume to get that product to market quickly. But on the back of that, we then won another contract with BMW. Now, BMW is clearly a larger supplier, a larger company, but there's a natural progression here where we tend to choose sort of small innovative companies because we want to get these really risky products to market quickly, and on the back of that we can crowd in much bigger sort of volume production of those semiconductors.
Okay, thank you, Chair.
Thank you. Paul Howell, please.
Yeah. Thank you, Chair. And I just want to touch on probably the argument starts with a subject we've all heard a lot of recently, which is about resilience. It doesn't matter which business sector we're talking about, and it's about where we should actually be in the UK. You know, we've seen that there's reports out there that say we shouldn't be focusing on onshoring the semiconductor industry, we'd rather play to our current strengths. Two parts of the question, really. One, what do you see as our strengths and comparative advantages? But also, do you agree with that argument, or do you think that we actually should be putting a more resilient picture more resilient structure into our UK offer? And I know, Martin, we've come to you, but feel free to put it to whichever of your colleagues are most appropriate for these answers.
If it's okay with you, I'd like Alistair to answer that question, please.
Okay, thanks, Martin. Thanks for inviting me. So I think it's a very large, complex industry, and it's not just a case of one type of semiconductor. It's a very broad industry with lots of different capabilities. You can generally describe it as three main elements to the semiconductor industry. You've got the manufacturing side where they actually make the chips, and that could be silicon or compound semiconductor. Essentially, it's very similar processes. You've then got the electronic system. So if it's an electronic system, it's got a chip in it. So there's all the work around taking a chip and putting it into, creating the electronics environment or solutions for different markets. And the UK is quite strong in that as well. And then you've also got the design side. So you've got the manufacturing of the chips, but then you've got almost a separate industry that can design the circuits that are used on the chips for electronics. So those three main areas. So then if you look at the UK capability in those three main areas, on design, you've got a world-leading UK design capability, primarily on silicon. So companies like ARM, Imagination, Dialog, and Silica, they all work on these sorts of silicon design technologies, the vast majority of which are not manufactured in the UK. They're manufactured in the Far East primarily, because the capital investment for those types of silicon technologies, if you wanted to build a new fab, so a fab is a semiconductor manufacturing site, we'll mention fab a lot. If you want to build a new fab in leading edge silicon, you wouldn't get much change out of about $20 billion. So there's none of that in the UK, that's in the Far East. However, in the compound semiconductor and older sort of silicon technologies, there's still a lot of silicon manufacturing in the UK, just not in leading edge. They still make a lot of money, primarily into automotive markets. There's UK capability there in older technology, silicon and silicon carbide, gallium nitride, compound semiconductors, and there's about 25 fabs in the UK manufacturing these types of technologies, and they've been around for a very long time. Once you establish something like that in manufacturing, it takes a very long time. It's very difficult to move because it's one of the most complex processes man has ever created, is to create a silicon chip. Right? And once it's there, it's very sticky. So you've got that in the UK for manufacturing, and then the post-fab or the electronic systems integration side, there's strength in the UK, particularly in power electronics, RF microwave, sensing and comms. So again, that's primarily in you'd say the compound semiconductor or hybrid technologies. So in each of those areas, there's technology. One of the issues you have in this industry is quite often, at the moment, there was a question about the recognition within industry of the semiconductor supply chain. Quite often within the semiconductor supply chain, it's not recognised. So for example, companies like ARM and Imagination, because none of the material they use to manufacture their products is done in the UK, they don't necessarily recognise a UK manufacturing capability. And vice versa, they're quite separate. In the future, there's the opportunity to take the UK design capability and bring that together much more closely with the UK manufacturing capability as those new technologies start to mature and reach wider markets. So that's one of the opportunities. So hopefully those three areas, yeah.
Thank you, Alistair.
Yeah, and I get that. I think just to follow the question just a little bit further. So what do you think are the real potential opportunities that the UK compound semiconductor industry should be looking to grasp?
Well, I would certainly say that in power electronics, so for example, every new Tesla on the road, the power chip for that is a silicon carbide power electronics chip. And the UK's got both manufacturing and supply chain capability in that area. And that's only going to grow. Most automotive manufacturers are looking to incorporate silicon carbide in their power electronics. It then goes into all the charging, vehicle to grid charging, it goes into the grid. And there's a new UK fab in Fife called Classic, which is a $60 million investment, which actually manufactures silicon carbide chips and is already pretty busy and starting to grow. So, and you've got other UK manufacturing sites who've got the capability to move to silicon carbide technologies. So that's an area where the global growth, particularly driven by automotive, is very, very high. And there's material supply issues even in silicon carbide at the moment. It can take a company about a year to wait on a silicon carbide chip, because at the moment volume, because of the electrification agenda, volume is vastly exceeding capacity at the moment. So there's an opportunity in these very quickly growing but relatively new areas for the UK to take quite a leading position. And that gives you're looking at security, the security of supply chain in electrification, you could argue is a pretty important area.
Thanks. And just coming back to what you said in terms of the structure, you've got your manufacturing, you've got your systems, you've got your design. But when it came to manufacturing, it seems as though you were saying basically, the chips are going to be made in the Far East. And if that's the
case, one type of chip. So the very advanced node silicon chips. So if you look at primarily, say, microprocessors for automotive, for example, that is most of that's in a lot of the consumer electronics is mostly Far East manufactured in silicon. But in the UK, you've got significant manufacturing capability in non-silicon or older silicon technologies. And it's still mostly silicon in the UK, and 90% of that is actually for export. So there's still significant. So remember, a fab is, depending on the technology, the capital investment, the cost of a fab is very different. So in most of the UK manufacturing sites, it's typically 50 to 100 million to build and run a semiconductor fab of reasonable scale in these sorts of technologies. If you're in the very, very leading edge silicon technologies, then it's just exponentially higher, and the UK is not in that space. But
sorry to interrupt you, but should it be? Are we in a situation where technology is just going to run away from us?
Yes.
In a past life, I worked up in what was then the Silicon Glen, and a number of the companies that were there just disappeared because they didn't keep up with technology. And if we need to be resilient as a country, do we not need to do something somewhere somehow? Is there just to broaden the conversation, is there some alternate things? I mean, I'm a North East MP, and I know that we've got people talking about using diamonds instead of silica. Is there something else that we should be taking, not just the silica agenda, in terms of where we go with semiconductors?
Can I invite Andy to make a comment on that, because he has written on this particular subject, actually.
Yeah, thank you, Martin. I think it's fair to say whenever you build an electronic product, it always has 2 or 3 types of semiconductor in it. So if I take your mobile phone, the brain is always going to be fabricated in silicon. The facial recognition is fabricated in compound semiconductors, and the 5G is fabricated in compound semiconductors. And actually, the display is a 3rd type of semiconductor. It's an organic semiconductor. So whenever you're building an electronic system, you always have 2 or 3 types of semiconductor. Alistair's absolutely correct. When it comes to the silicon, UK is preeminent in the design space. When it comes to fabricating silicon, we tend to fabricate on older design processes, typically sort of 1990s or early 2000 design processes. I think for the resilience and the security piece, there is certainly an opportunity where Alistair has said we have about 20 to 25 fabrication facilities in the UK. And you're quite right, there's one in Newton Aycliffe in the northeast, several in Scotland, in Greenock, in Manchester, Oldham, Hazel Grove, etc. There is an opportunity perhaps to support those fabs to move to a more newer process and to secure higher functionality on the chips that they're fabricating in silicon. That would certainly, it's a growing market, and it would certainly make the UK more resilient and secure in that space. I think on the compound semiconductor space, we have great research base, and we have some really sort of great companies, and Alistair has alluded to Classic in Scotland, which is growing very well. I think there's also an opportunity here to support those companies for scale-up in particular. These are rapidly growing markets, and again, when it comes to resilience and security, you need a couple of elements. You need the design elements, but you also need the fabrication elements. So I certainly think there's an opportunity to support those companies in growing those particular areas. Thank you.
Okay, thanks for that. The one you mentioned at Newton Aycliffe is 2.6, and it's in my constituency, so yes, I'm very familiar. Thank you, Chair.
Thank you.
That was the note I made as well. Thanks.
Thank you, Paul. Martin McHugh, the resilience of UK assets has been in the media quite a bit recently, predominantly because of the National Security and Investment Act interventions on Newport wafer fab and the question around the listing of ARM now the acquisition by NVIDIA has collapsed. Do you think at the moment there is a clear message from government to the industry about what ministers think about intervention in this market and which assets it wants to protect and which assets it doesn't want to?
I won't say there's not a clear message. I think there does need to be a clear message. So one of the things the Catapult has observed at the moment is there are a number of initiatives across various departments within government. There are a number of industry trade bodies such as the Motor Vehicle Manufacturers and Traders Association, obviously lobbying the government. And we have our fellow Catapult, the Royal Academy of Engineers and other institutes actually commenting on and reviewing the semiconductor industry. And I think what that's actually presented is a situation for industry is that it's unsure where to turn within government to actually voice its opinion. So I think first of all, we welcome the elevated profile that the semiconductor and compound semiconductor industry is now getting with government. I think the next stage for us would be to try and get a unified position and voice across all of government. And I think that would make it easier then for the industry that we represent.
Do you think it'd be better for the work on semiconductors to be moved from DCMS into BEIS so it's all in one place? Or do you think we can get to a position where all the departments are kind of doing the same thing?
I think it'd be great if we could get to a position where all the departments are doing the same thing. I know we have to, as a Catapult, the one thing that we have to remain clear on is our neutrality. Industry trusts us, government trusts us, trade associations trust us, universities trust us as that neutral convener. So it's always really a position for us that we have to kind of maintain that position of neutrality so that people can actually trust us with their opinions and then we can actually convey those opinions back out. As I said, for us it would be easier if there was a single voice from the government, even if that was made up of two departments.
And on the basis of that answer, if I were to ask you your view about Newport wafer fab, presumably you would tell me you wouldn't be able to give me an opinion.
So again, on Newport wafer fab, we have a position of neutrality. We have to think of the UK as a whole. So our view would be, and it was picked up with the fabs that were mentioned in Newton Aycliffe in Scotland, we would say our particular interest within the compound semiconductor industry across the UK is to make sure that there is actually targeted investments within the compound semiconductor industry in building the supply chain up across the UK. And that would include, Scotland, North East, South West and South Wales as well. And
I think the Foreign Affairs Committee suggested that the government should play a role in any listing of ARM and maintain some kind of, I think it's golden share, I think was the phrase they used. Would you agree that it would be beneficial to the industry if government had that kind of level of intervention around ownership or investment directly in companies?
I think it's a position we would rather not comment on at the moment. It's protecting our neutrality from an industry point of view and a government point of view.
Okay, I'm feeling generous today, so I won't push you. Paul Howell, please.
Thank you, Chair. Just coming back to what we touched on a little bit there in terms of the whole supply chain structure, and we've talked about the different bits of the business already, but just how resilient is the UK when it comes to the supply chain? Are there gaps in it? What's the structure like? Is it fragmented all over the UK, or are there clusters that are in different parts? Is it just certain things in the southwest, certain things in the northeast, certain things in Scotland? Should it be encouraged to be more, a collaborative structure, or is it just the way that it's evolved? What do you think we should be looking for there? And are there any particular gaps that we should be particularly concerned about, other than what we've already covered, obviously?
Okay, I'll start that and then pass to Andy. So yes, there are recognised clusters within the UK. The Catapult have actually mapped those out. Good examples would be we recognise a very strong RF cluster in the northeast that would benefit from targeted investment. We recognise a very strong cluster within Scotland around heavy power and satellite applications that we think would benefit from targeted investment. Certainly within South Wales and the cluster we're actually located in, and then there are clusters in and around the east of England and down in Torquay in the southwest. So one of our roles is we believe that those clusters could actually benefit from having supply chains formed around them and actually connecting the various supply chains and actually making sure those supply chains are there to support those particular clusters as well. And that's one of the roles of the Catapult. I'll ask Andy and Alistair in turn to just add to that as well. And Andy's got a particularly good map of the Catapult network behind it, just shows how wide everything is. Andy, go on.
Sure, thank you, Martin. I think you're right. I think when it comes to compound semiconductors, we do have elements across the supply chain. So in design and research and fabrication, where they could do with a bit of assistance is in the scale-up, particularly to address these large markets of vehicle electrification, 5G satellite communications. Our Catapult is actually located with IQE, a world-leading provider of compound semiconductors for facial recognition and 5G, for example. So we really are in the heart of that particular cluster. When it comes to silicon fabrication, as we alluded to earlier, we have very big strengths in design, but there is some patchiness. So for the high-end silicon chips, they're all fabbed in the Far East. Now the UK is not unusual in this particular situation. So when you look at all the major developed economies, the US, the EU, they all buy their high-end silicon from the Far East. We're not unusual in that particular situation. But compound semiconductors, we have good representation across the supply chain. Thank you.
Yeah, I would say that if there's one gap we've not talked about that the UK doesn't have is what we call base wafer growth capability. So obviously the fabs, all the action happens on the very top surface or epi layer of a semiconductor wafer. And Andy mentioned IQE, so they're world leading at developing that epi layer, and then it goes to a fab. But the epi layer is built on usually a 6 or 8 inch diameter wafer of different types of material. There is absolutely no UK capability in that space, so that's always a supply chain gap. And in some cases, you could argue that it would be good to have some UK sovereign capability. I think particularly in things like silicon carbide, which is very difficult to grow. But that's a definite gap. The closest to it is our company in Livingston, Shinetsu, who are the wider global company grows silicon wafers, but in Shinetsu, again, it's epilum. So that's one gap. In terms of the clusters, so yeah, I think historically you've ended up with fabs all over the UK, but there are clusters which you can pick out and develop. So in the northeast, you've got 26 in Newton Aycliffe. You've also got a little company called Inex, which is the old Newcastle University fab that's looking to move, expand and grow. Both of those have two of the base technologies for future RF chips, gallium nitride and gallium arsenide. And then in Scotland, you've got, there's a sort of national focus on energy, hydrogen, high power HGVs, and that goes well with the silicon carbide capability that's being developed. In the southwest, you've got Plessy doing LED development, and that fits very well with the southwest sort of photonics cluster. So you can see where there are at least centres of gravity, but there's always exceptions to the rule as well. But you can certainly build around supply chains around centres of gravity to grow those new supply chains.
Okay, and just a final sort of question onto that. We had talked about we could invest, we could do this. What sort of support do you think is appropriate? Is it a private sector thing? Do we need some government intervention there? Is there some sort of incentives? Or will the market take care of itself? What do we need to do to make sure we try and fill those gaps as time goes on?
I would say certainly we've talked about targeted investment to help. It's got to be industry-led. So there's got to be the will from a company to establish these very complex, high-cost capabilities. That's got to be there, but incentive-based, into say, research or just to help, perhaps capital investment to improve capacity, for example. You've got those 20, 25 companies in the UK have been there for a long time, a lot of them, and they make a living. They do quite well, but there may be some targeted investment to help them grow and scale or adapt to new technologies. The sort of innovation help that would help these companies. If you're looking at the sort of high-end silicon, the only feasible way to move into the really the 20 billion level is to be able to attract inward investment, where you've got one of the big companies like TSMC, for example, or Global Foundries, with the UK making the case that it would be good for them to build a site and invest in the UK. It's not something you could start from the ground up. It's just too complex. It takes years to develop a fab in the semiconductor technology. Even the new one I talked about in Fife on silicon carbide, that's taken them 4 or 5 years to get to where they are. It's just early production. So it's very complex. So you need to have industry-led investment with some help to incentivise.
Thank you very much, Chair.
Thank you. Mark Pawsey, please.
Chairman, just a quick one. We've heard that this is an industry with lots of collaboration and we've got clusters, but Alistair's just told us that there's some areas with no UK capability and it would take a massive amount of time to develop our own capability. What potentially exists for international collaboration that we could work with some of these dominant players in the Far East? Can we work with them to establish domestic manufacture in the UK?
Sorry, go ahead.
Sorry, Alistair, I was going to let, if that was okay with the committee, let Andy have 2 minutes on that, because he's done a lot of work with international collaborations for us, actually, and then Alistair, you can pick it up. And thanks.
Yes, thank you for the question. I think it's right. I think actually it's very difficult for any one country to have a complete sovereign capability in everything. And the integrated review, which was published in 2020, gives us a really good framework about how we should go about collaboration. So the integrated review talks about own, access, collaborate. And own is where the UK has research and fabrication capability and supply chain capability. You can own an area. And arguably, I would say that we can own the compound semiconductor area. The collaborate is where the UK has parts of the supply chain or parts of the technology, but we still need the technology. So perhaps the collaborate is where we get the higher end silicon. And then the access is where we have less of that. We need to sort of get access.
And are those discussions taking place now?
To a certain degree, yes. So I've been out to Taiwan and I've also been out to India. Now, the thing about these partnerships is you want a trusted partnership. You want and equally the EU and the US. So I shouldn't just highlight, I should highlight the US, the EU, India and Taiwan as being trusted partners where they have complementary technology to what we have. And they are also doing quite large-scale investments. So Taiwan is really the home of the high-end silicon fabrication. India is looking to incentivize companies to grow high-end silicon or medium-end silicon fabrication. So we can partner with these countries. We're having sort of intermediate discussions with them at the moment. The US has announced the CHIPS Act in order to become more self-reliant on high-end silicon production, and the EU is also investing heavily in this space.
Okay, thank you. Thank you, Chair.
Thank you. And lastly for this panel, Alan Brown, please.
Thank you, Chair. Just moving on to compound semiconductor demand, just wondering if somebody could explain how much of what's made in the UK is actually used in the UK as an end product, how much is exported, but also then how does the export value compare to the amount that needs to be imported because of the high-end stuff that comes in from the Far East?
Do you want to take that, Andy, or do you want me to take that?
I'll have a start if that's okay, and then perhaps you can chip in, Martin. Certainly, IQE is a world-leading provider of compound semiconductor EPI wafers. So my understanding is they export a large proportion of what they do. I'm also aware that in 2005, Piltronic in the Northeast exported nearly 300 million compound semiconductor devices to the US for the mobile phone industry. So we do have some sizable sort of market exports in this area, but equally it's a global market. So we're not just supplying the UK; we're supplying into a global market. Thank you.
Okay, and I was just going to say, just for some reference numbers, that some of the numbers we have is the world market for compound semiconductors was around about 32 billion in 2020, and expected to grow to about 43 billion in 2025. And the UK market would be about 7 billion. And what I wanted to add then is that within the cluster here in South Wales, 95% of the output of the cluster is actually exported, because it's not just for electric vehicles, it's for mobile phones and other devices. So yeah, I hope that kind of answers your question.
Yeah. Okay. Just one kind of final question. I think it's probably for Alistair. How do you envisage the demand for compound semiconductors will change in the future? And is the UK capable of meeting that demand? Now, we've already heard different things about industry needing our government speaking one voice, need inward investments. What would be the kind of key ask then, just to make sure the UK is well placed to meet that future demand?
Yeah, I think there's probably three elements. So compound semiconductors are still relatively new, so there's an opportunity to grow in those areas: power electronics, communications, sensing. So where we would see probably the three main likely interventions there is, one is selective targeting of semiconductor manufacturing investment across the various capabilities in the UK. The post-fab, the electronic systems side, there's existing capability there. Andy talked about the project we've done where we've developed a supply chain that goes up through to McLaren and now BMW in power electronics. So bringing that industry together in electronic systems integration is important, because again, there's bits of IP all the way through up post-fab. When you're putting the system together, that's where we stand. So in both silicon and compound semiconductor technologies, that's important. And then the third area is really exploiting the great design capability we've got in the UK. So as the compound semiconductor technologies become more mature, they move to they could be more generally used by designers and solution providers in electronics. And that's where the design community can come in. As that becomes more commoditized, then more accessible, then the UK design capability is potentially a good position to sort of start to work much more closely with the UK manufacturing post-fab supply chain than it's done previously. And that's more a sort of industry networking and integration challenge, I would say. But those would be the three areas. And then you're positioning yourself. Yep.
How would that collaboration early enough in the process come about to make that much more coherent and then create these additional jobs? We can give some examples. I think developing products and solutions, even at an innovation level, to bring the supply chain together into collaborative projects works well. We've seen that happen in power electronics. We've seen it in RF. So an example would be this, the project called Escape, which we helped. We worked with the UK industry to develop. So that's a 12-partner end-to-end supply chain in silicon carbide power for automotive. It started with IQE in South Wales. The fab was in Classic in Scotland. Several different packaging companies around the UK, and then Turbo Power Systems in the Northeast doing a solution. McLaren Applied doing a solution. So you've then got a demonstrator of a full UK end-to-end supply chain with product. And that exercises the work. It's not creating a hermetically sealed supply chain.
what then happens is those companies can then go and work with whoever they want globally. They're showing what they can do, and then you're creating that capability, and then other companies can start to be partners within that. So you're not just creating one supply chain, you're creating width to the supply chain and having 2 or 3 fabrication capabilities or 2 or 3 design capabilities. And that's what gives you strength in a cluster, not just one thing. So I would say that would be a very good way to go as you look at those new technologies, encouraging supply chain collaborations.
Okay, thanks.
Thank you, Alan. Thank you to Martin McHugh, Alistair McGibbon and Dr. Andy Sellers for your contributions this morning. We're very grateful. We're now moving on to our